solved problem 1.5 from the book Heat Transfer 10th edition, J.P. Holman's. Here is the statement: a certain superinsulation material having thermal conductivity of 2 multiplied by 10 to the power minus 4 watt meter centigrade is used to insulate a tank of liquid nitrogen that is maintained at minus 196 centigrade, that is the inside temperatures of the cylinder of the sphere, and the heat that is required, 199 kilojoule, is required to vaporize each kilogram of mass of nitrogen at this temperature. Assuming that the tank is sphere having inner diameters of 0.52 meters, estimate the amount of nitrogen vaporized per day for an insulation thickness of 2.5 centimeter and ambient temperatures of 21 centigrade. So the inside temperature, so here I will draw the simple schematic diagram of the sphere. That this is the sphere. So the inside temperature here is T1, so that is T1, and the outside temperatures, that is T2. Okay, now the inside dia, that is also provided. What is the inside dia? That is 0.52 meter in this problem, and now this thickness of this sphere tank is also provided, that we call it, so this thickness we call it x, and that is 2.5 centimeter. If you convert that into meter, just divide it with 100 and you will get that is 0.025 meter. Okay, next we need to find what is the outer dia of this sphere. So the outer dia will be the sum of the, so the outer dia will be equal to sum of the inner dia plus 2 times of this thickness, so the thickness that is provided. So what is the inner dia? That is 0.52 plus 2 times of the thickness, that is 0.025. So the outer dia you will get, that is equal to 0.57 meter. So the heat transfer is taken place from outside to the inside. Remember, the heat transfer will take place from outside to the inside. Due to this heat transfer that is taken place from the outside to the inside, the nitrogen that is present inside this sphere will get vaporized. When everything gets heated, it gets vaporized. So in our case, the temperature inside this sphere is lower, that is minus 196 centigrade, and the outside temperature is 21 centigrade. So the heat transfer will take place from outside to the inside, and we need to find how much nitrogen is vaporized per day, so we need to find amount of nitrogen vaporized per day. So first we need to find how much heat that is equally transferred to this sphere. So that is from this formula we can easily calculate, that is equal to 4 pi k temperature difference. So what is the temperature difference? That is T2 minus T1 divided by 1 divided by R1 minus 1 divided by R2. So in this case, what is R1? So the R1 value is inside diameter divided by 2, and that is 0.52 divided by 2. So when you divide it with 2, you will get the R1 value, that is 0.26 meter. Now what is R2? That is outer dia divided by 2. So what is outer dia? That is 0.57 divided by 2, and then you will get that is 0.285 meter. Now put all the values in these corresponding formulas and you will get the heat that is transferred inside this sphere. What is K value? That is 2 multiplied by 10 to the power minus 4. What is T2? That is 25. So this minus will become plus 196, and then divide it by 1 divided by 0.26 minus 1 divided by 0.285. Let me calculate it on calculators, that what will you will get. So after solving this on the calculators, you will get that is the heat transfer has become 1. So after calculation it will become 1.617 watt. Now in the statement they say that this much, when this much heat is provided, it will produce 1 kg of nitrogen vapor. So now if you come to this statement, so if this much heat is supplied inside this tank, then 1 kg of mass of nitrogen will be produced. So I can say that the mass of nitrogen evaporated, that will be equal to 1.617 divided by 199 kilojoules. So kilojoule means multiply with 1000. So this will convert into kg per second. So after calculations on calculator, you will get its value, that is 0.813 multiplied by 10 to the power minus 5 kg per second. Now we want to find how much nitrogen is evaporated per day. It's very simple, just multiply this value 10 to the power minus 5 with in 24. So in one day we have 24 hours, and then in 1 hour we have 60 seconds, and then in 1 minute we have 60 seconds. So after multiplications, you will get the mass that is generated per day. You will get that is 0.702 kg per day. So when the heat transfer is taking place from this from outside to the inside of this tank, this much 0.702 kg of nitrogens will evaporated per day. And this is our final answers. I hope you understand. If you still have any confusion, you can ask. Thank you.